All right, let's do some graphing. So still doing trig, we will be for a while. Well, I guess last chapter was graphing too, wasn't it? This is a different type of graphing. Let's graph the whole darn sine function, not just one precise angle of it. So, got a big list, huge table here. Let's fill her in. If x is 0, and I'm graphing that, I put 0 where x is and find out what y is. We should know that. What is the sine of 0? Let's do a unit circle. Okay, so here's some angle, and we know x is the cosine of it, right? And y is the sine of it. When this is 0, x, as in the angle, well, that goes down to 0. What is my y? If this is a unit circle, the radius is 1. Well, how big is that opposite side if the angle's nothing? But don't believe what I say. Sine of 0. Hey, what do you know? Pi over 6. We should know that. And some of you did a few days ago. Pi over 6 is the same as 30 degrees. What's the sine of 30 degrees? 1/2, good. What's sine of pi over 4? Yep. Which is, I mean, how do I plot this thing? What is that approximately? Let's find out. 1 over root 2, approximately 0.7. Okay, 7/10. Oh, approximately root 7. Sine of pi over 3. Sine of 60 degrees. Let's do this guy. Good, some of you got it. That's going to be a root 3. This one is pi over 3. That one was pi over 6. So sine is opposite over hypotenuse. Anyone know what that is as a decimal? .86. Well, approximately, like we don't have much precision here. That's approximately 0.9. Okay, 9/10. And sine of pi over 2. So as this angle gets bigger and bigger and bigger, that's 0, that's pi over 2, that's pi, that's 1.5 pi, and then we're back over here and we got 2 pi. So as this opposite side gets bigger and bigger and bigger and equals the radius, then what is 1 over 1? What's sine of 90 degrees? Don't believe me? Put it in your calculator. Okay? The opposite is as big as it possibly could be. There is no triangle here. But that's okay, because you're in grade 12. You can handle that kind of stuff. Okay, so now, 2/3 pi. Where's that? Well, let's break it up in thirds. Over here is 3/3 pi. So there's 1/3, there's 2/3 pi. And what is that? What's my reference angle here? 60 degrees, pi over 3. I've already done this, haven't I? It's 0.9, root 3 over 2. Is that positive in this quadrant? For sine? Yeah. So it's approximately 0.9 again, right? 3/4 pi. Well, there's 1/4, there's 2/4, or pi over 2, there's 3/4, there's 4/4 pi, right? So 5/4, what am I looking for? Yeah, 3/4 pi. I'm at 3/4 pi. Okay, I don't want to go that far. I want to go right there. What's my reference angle? Pi over 4. I've already done it. It's 0.7. Is it positive or negative in this quadrant? Positive. Approximately 0.7. 5/6 of a pi. That's not quite over to 6/6 pi. That's about 1/6 away. 5/6 pi. What's my reference angle? Pi over 6. I've already done it. And in that quadrant, it's still positive. Okay? That's exactly 0.5, not approximately. Sine of pi, which is 6/6 pi, whatever you want to make it as a fraction. What was it over here? It was 0. Guess what it is over here? It's 1 here. So what is the sine of 180 degrees? What is the sine of pi? I'm in radians. 0, right? Still 0. Let's go to degrees. What is the sine of 180 degrees? How big is that opposite side over there? How big's my opposite side there? It ain't there at all. There's no opposite. Same as over here at 0. Okay? 5/4 pi. Well, let's actually do another one down here. Say there's 4/4. So 5/4. My reference angle is pi over 4. That's 1 over root 2, which is 0.7. But in that quadrant, it's negative for sine, right? 3 over 2 pi. There's pi. There's 1.5 pi. There's 2 pi. Okay, so 1.5. What is on my unit circle? This gets opposite side, gets bigger and bigger and bigger until it's right on top of my radius. So it's 1, but yeah. Let's try it. Radians, I could put in 270 degrees. That would work too. But what is sine of 3 pi divided by 2? That's 3 over 2 pi, right? Okay, -1. 7/4 is 1/4 away from 8/4. 0.7. Is sine still negative down in quadrant 4? And 2 pi, isn't that the same as 0? What was the sine of 0? Okay, let's plot. So I've got some units here. Y goes from 1 to -1. Is that as big as y got here? Is that our range? Well, lucky you, we gave it for you. Let's look down here. What's going on? It's going all the way up to 2 pi. Okay? We're starting here at 0. We're going to negative pi over 2. So each one of these lines is what? Let's cut this in half. That's 2 pi. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Half of it would be 12, which is, darn it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's half. There's pi. What's half of 12? Which is half of pi, which is pi over 2, right? 1, 2, 3, 4, 5, 6. So each one of these lines is what? If it takes me 12 to get to pi, isn't that 12/12 pi? So each one of these is 1/12. So that is pi over 12. This is 2 pi over 12, otherwise known as, what's 2/12? 1/6. What's 3/12? Okay, pi over 4. Okay. What's 4/12? Pi over 3. Or, if 2 of them are pi over 6, then 4 of them are pi over 3, right? That's double pi over 6. Because these are the stuff I want to plot, right? So, speaking of which, let's plot. 0 is 0. Okay? So, wouldn't it be nice if each one of these was a tenth? It is. Okay? There's 10 lines from 0 to 1. So pi over 6 is 0.5. There's pi over 6. 1, 2, 3, 4. There's 0.5. Halfway to 1. Right, Brianna? You may want to pay attention. Because I'm only recording this for kids that didn't get it the first time. If you don't try to get it the first time, maybe I won't record them. Pi over 4 is 0.567. Pi over 3 is 0.9. Pi over 2 is 1. And then what? I got pi over 9, 2/3 pi. Any guesses where that is? That's 6/12. What's 2/3 pi in terms of twelfths? Yeah, 6, 7, 8. You notice something up here? Does that kind of look like maybe it's symmetrical? It is. So if I go down to and over 1, I bet you that point's right there. How great. Okay, 3/4 pi, that's 9/12, 12, 11, 10, 9/12. There it is. 0.7. If I go down to and over 1, I bet you that's 5/6 pi is 0.5. And then pi, that's there, is 0. Does it look symmetrical? It should. So now, what happens? I get into the negatives. 5/4 pi. So that's 1/4 past 12/12. 1/4 is 1, 2, 3 lines, right? So if I go 1, 2, 3 lines, that is negative 0.7. 1, 2, 3, 4, 5, 6, 7. That 5/4 pi. You can't see that, but I can. I gotta move that. That's my projector doodad. Okay, 3 over 2 pi, where's that? That's 1.5 pi. That's halfway between 1 pi and 2 pi. 1, 2, 3, 4, 5, 6. And what's the value? -1. Let's make it really big because I've put my line. It's symmetrical. So if I got that point right, 1, 2, 3 over and 3 up, 1, 2, 3 over and 3 up, then that one should be right. How many more do I have? I did that one. I just did that one. I just got that one to go. 2 pi is... Now do not connect... What was I going to say? Do not do a line of best fit. We want to connect the dots. I almost told you opposite of what I wanted to tell my grade 10s. Okay? So, who uses the furry shade method? I know Anya does. I'm not saying it's wrong. It's just some of us do a one line and some of us do the kind of the sketchy part thing, right? I'm just going to make tiny little lines and sketch along. We all have different ways of graphing. I did it both ways because I'm multi-experienced and multi-talented. Look pretty? Do you think it stops there, or does this thing keep going on and on and on?
Keeps going.
It's a sine wave. Did someone use the word wave? That's science. This is math. There's no crest on this thing. There's no trough down here. This isn't science. Okay? There's no point where the amplitude or the energy of this wave is zero, like this line right here. Anyone use electricity? Oh, you do? Good. It's a sine wave coming out of the wall with a frequency of 60 hertz. That's what it looks like if you could see it. Really, really, really quick. What's the amplitude? It kind of depends on voltage and the current, right? This has arrowheads. It keeps going. That is one complete, what's the word? One complete cycle of a sine wave. It continues. Remember that frequency period stuff in physics? Frequency is 1 over the period, right? This is one complete cycle from there to there. One complete crest, one complete trough. Okay? What is the period of this thing? What is the time for one complete cycle? From 0 to 2 pi. Right? Period is an inverse relationship with frequency. What's the domain? Domain here is x, so we're going to call it x. Maybe in your assignment they won't have an x there. Maybe they'll have a theta, in which case your domain is in terms of theta, not x. But we got an x. How far does this go left? I didn't plot the negatives, but I could have. It would have been the same thing, just another, the one that way. It would have been another one that way. What's my domain? Is there any value of pi this thing won't get to? So how do I say that? Like that. All real. It's continuous, right? All these points have meaning. Range, what's the minimum, what's the maximum? Y is less than or equal to 1, greater than or equal to negative 1, where y is all real. X-intercepts? Well, this is x. It crosses it here, 0. Okay, where's the next one? Crosses it here, pi. Where's the next one? Crosses it here, 2 pi. Do I want to write out absolutely infinite numbers of that, or is there some kind of a formula I can use to write my x-intercepts? This is multiples of what? Where do you think the next one will be? 1 pi, 2 pi, 3 pi, 0, 1, 2, 3. What do we call these things? I can go negative too, right? Is that an integer? There's my x-intercepts. N pi, where n is an integer. It can be, like, I've just graphed the whole numbers, but like I said, we can go negative too. Y-intercepts. Where does this cross the y-axis? Right there. What's the value? Y-intercept is 0. Just two more, maximums and minimums. Where's the max? Right there. What's the value? Pi over 2. Is there another one? Do you see where the next one will be? Is it going to be pi later? It's a 2.5 pi. Is it 2 pi later? Pi later? Where's the next max going to be? Plus 2 pi, right? And on and on and on. How do I want to write that? Pi over 2 plus or minus 2 pi n. Every 2 pi, this cycle repeats, right? So I don't care what point you're looking at, 2 pi later, I'm going to get the same point. If I'm looking at this point, 2 pi later, I'm going to get the same point. Where's the minimum? 3 over 2 pi, or 1.5 pi, right? And every 2 pi, that's going to repeat. So if I times that by n, where n's an integer, that's the whole list. That's every minimum for this graph. You guys ever tried this? That's not that exciting though. That's in radians. What if I go from 0 to, what was this? 2 pi? And this graph goes from -1 to 1. Is that pretty much what we got here? Yeah. Now what did the window do? Did you notice when I put in 2 pi? Yeah. What's 3.14 blah 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 times 2? Yeah. Okay. 6.28. That is exactly one cycle of sine wave from 0 to 2 pi. Okay, here's a website I guess we'll be playing with tomorrow or the next day. We can actually see what some transformations will do to this. So quickly, that's sine wave. Let's see if we can do cosine a little faster, because it's a wee bit different, but a lot of similarities. Cosine of 0. If this angle is squashed down to 0, cosine is my x. What can I say about x there? It's 1, right? Like this x part will be right on top of my radius, which is 1. So what's 1 over 1? If you don't believe me, put it in a calculator. Cosine of pi over 6 is √3 over 2, which was 0.9. Cosine of pi over 4 is 1 over √2, which was about 0.7. Cosine of pi over 3, cosine of 60, that's the same as sine 30, that's a half. And what is my x value right at the top here? 0. Okay? So again, this is 0, but now I don't start at 0, I start at a maximum, not a minimum for cosine. Pi over 6 was, let's cheat. Okay, each one of those was a 12th, so pi over 6 was 2 lines. Okay, which was 0.9. Pi over 4 was the next line, that was 0.7. Pi over 3 was double that, so I go 4 lines, and that was 0.5. And pi over 2 was 1, 2, 3, 4, 5, 6, which was 0. Okay, is this thing symmetrical? It is. So if I do that, okay, this point is 2 over and 1, 2, 3, 4, 5 up. Go 1 more over and 2 more up. Go 1 more over and 2 more up. And then go 2 over from there and 1 up. Oh, it's negative. Okay, duh. All right, I better do it. 2/3 pi. Negative 0.5. Okay, what was that? There, 1, 2, 3, 4, 5, 6. Negative 1/2 pi. 2 over there. Okay, 3/4 pi, 0.7, negative 5/6 pi, 0.9, negative. Pi is negative 1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And it's symmetrical. Okay, now I can do that. Is that one complete cycle? That's from the crest to the crest, isn't it? It is. It's one complete cycle of a cosine wave. But we just started at the maximum, okay? Not the middle point, if you will, for the sine wave, okay? That's one complete crest, one complete trough. You remember Science 8? There's one complete crest, and here's one complete trough. So that is one full cycle. Period. 2 pi for one complete cycle. Domain, this doesn't stop. It keeps going. X is all real. What's the range? Same thing. From -1 to 1. X-intercepts. Pi over 2. And where was the next one? 3 pi over 2. But how do I get them all? All I do is need the first one, and then what do? Every 2 pi, this thing repeats. So it's just 2 pi n. Oh, I'm sorry, just pi n. Y-intercept at 1. That's where it starts. Okay, that's where x is 0. Always, 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 right? Maximums. 1, which was 0 and 2 pi. And where's the next one? 4 pi. So it's 0 plus or minus 2 pi n. Every 2 pi, this thing repeats. Minimum there at pi. And every 2 pi. So, your assignment, you're going to graph this thing, but you don't need to do every point. Okay? So when you look at the assignment, This takes quite a while, and it is good knowledge. But what you're going to do is just plot that point, that point, that point, and that point, and that point. Okay? So we know the shape of this thing, so we don't need to put in every little special angle in here. Okay? So plot that one, that one, that one, that one, and that one. All right? So for example, sine of theta from 0 to 2 pi, here's how quick it is. What's half of 2 pi? This thing goes from what to what? And sine starts where? That's the knowledge of the y-intercept. Okay, where is it a maximum? Pi over 2. Here, it's 0 again. So if I know that, do you know where it goes now? Yeah, it's got to go down here, doesn't it? At 3 over 2 pi. Okay? And then, well, it repeats itself. Okay, so that's a good 10-second graph of sine. Shows a lot of knowledge. That's what we want. Well,